back to my YouTube channel. So again, my name is Rica from the Electronics Engineering Department of the De La Salle University Das Marinas. And for today's experiment, we'll be having our data communications experiment number 7 entitled Design and Implement a VLSM Addressing Scheme. So for our topology, we'll be considering this S1, which is our server 1. And then we'll also be, so we also have here our VR1, our VR2, and our server 2 here on the other end. So for our objectives, we'll be having our part 1. So we will be examining network requirements. And for part 2, we're going to be designing the VLSM address scheme. And then for our part 3, we'll be having cable and configuring the IPv4 network. So for our background and scenario, Variable Length Subnet Mask VLSM was designed to avoid wasting IP address. With VLSM, a network is subnetted and then re-subnetted. This process can be repeated multiple times to create subnets of various sizes based on the number of hosts required in each subnet. Effective use of VLSM requires address planning. So in this laboratory experiment, we'll be using this network address to develop an address scheme for the network displayed in the topology diagram here on the top side of our paper. So VLSM is used to meet the IPv4 addressing requirements. So after we have designed the VLSM address scheme, we will configure the interfaces on the routers with the appropriate IP address information. So the future LANs at VR2 will need to have addresses allocated, but no interfaces will be configured at this time. So for our required resources, we'll be needing 2 routers, 2 switches, 1 PC, console cables to configure our Cisco iOS devices via the console ports, Ethernet and serial cables as shown in our topology and Windows calculator. By the way, this is switch 1, okay? It's not a server, but it's switch 1 and switch 2. So now let's start with the part 1. So now for our instructions for part 1, examine network requirements. In part 1, you will examine the network requirements to develop a VLSM address scheme for the network displayed in the topology diagram using the 192.168.33.128-25 network address. So note, you can use the Windows Calculator application and search the internet for an IP subnet calculator to help you with your calculations. So for step 1, determine how many host addresses and subnets are available. So for the first question, how many host addresses are available in a 25 network? So the answer is 126, this one. So for the next question, what is the total number of host addresses needed in the topology diagram? So our answer for this is 80 host addresses for the topology diagram above. Okay, then we're gonna have here, okay, let's go back. How many subnets are needed in the network topology? So the subnets needed, or the number of subnets needed is 6. So for step 2, we will be determining the largest subnet. So for the question, what is the subnet description? So for this question, what is the subnet description? So our answer is PR1 LAN 40 hosts. So for the question, how many IP addresses are required in the largest subnet? So the total number of IP addresses required is 40 IP addresses. So what subnet mask can support that many host addresses? So the subnet mask will be, so that's going to be /26 or 255.255.255.192. So how many total host addresses can that subnet mask support? So it will be a total of 62 host addresses. So can you subnet the 192.168.33.125/25 network address to support this subnet? The answer is yes. So what are the network addresses that would result from this subnetting? So the network addresses will be 192, this one, 192.168.33.128/26 and 192.168.33.192/26. So use the first network address for this subnet. So this will be our answer, 192.168.33.128/26. So for our step 3, we will be determining the second largest subnet. So what is the subnet description? So our subnet description will be BR2 LAN 25 host. How many IP addresses are required for the second largest subnet? So we'll be needing here 25 IP addresses. So what subnet mask can support that many host addresses? So our answer is /27 or 255.255.255.224. Then we're going to have how many total host addresses can that subnet mask support? So the total host addresses will be 30 host addresses. So can you subnet the remaining subnet again and still support the subnet? The answer is yes. So, yep. So for the next question, what are the network addresses that will result from this subnetting? So the network addresses will be 192.168.33.192/27 and 192.168.33.224/27. Use the first network address for this subnet. So our answer will be 192.168.33.192/27. So for our step 4, we will be determining the third largest subnet. So our first question will be, what is the subnet description? So our subnet description will be BR2 IoT LAN description. IoT LAN 5 hosts. How many IP addresses are required for the next largest subnet? So we'll be needing 5 IP addresses. So for our step 4, we'll be having this one. What subnet mask can support that many host addresses? So our answer will be /29 or 255.255.255.248. So how many total host addresses can that subnet mask support? So we'll be having 6 host addresses in total. So can you subnet the remaining subnet again and still support this subnet? Of course, yes. What are the network addresses that would result from this subnetting? So our answer will be 4 network addresses. So there's 4. So I'll just be giving you the first 2. Okay. So the first 2 will be 192.168.33.224/29, and the second will be 192.168.33.232/29. So use the first network address for this subnet. So our answer for this one will be 192.168.33.244/29. So use the second network address for the CCTV LAN. So our answer will be 192.168.33.232/29. Then use the third network address for the HVAC/C2 LAN. So our answer will be 192.168.33.240/29. So for our step 5, we'll be determining the fourth largest subnet. So what is the subnet description? Let's proceed here. So our subnet description will be BR1 dash BR2 link. That will be 2 hosts. Then how many IP addresses are required for the next largest subnet? That will be 2 IP addresses. What subnet mask can support that many host addresses? So that's going to be /30 or 255.255.255.252. So how many total host addresses can that subnet mask support? So that's going to be 2 host addresses. So can you subnet the remaining subnet again and still support this subnet? Of course, the answer is yes. What are the network addresses that would result from this subnetting? So our answer will be 192.168.33.248/30 and 192.168.33.252/30. So use the first network address for this subnet. So our answer will be 192.168.33.248/30. So for our part 2, we'll be designing the VLSM address scheme. So for the step 1, we'll be calculating the subnet information. So use the information that you obtained in part 1 to fill in the following table. So for our subnet description, we have here 5 subnet description with the given number of hosts needed, which are 40, 25, 5, 4, and 4 respectively. So with that, we'll be having the network address or the CIDR for all of the given. So as you can see here, I'm not going to be saying it one by one, but you can check it in your screen. You can see the answer. So we have here the network address or the CIDR. We're going to have also here our first host address, okay, for each of the subnet description. Then we also have here broadcast address for each of the subnet description as well, respectively. Oh, before I forgot, we have here actually six subnet descriptions for designing the VLSM address scheme. So we still have another one here, which is BR1-BR2 link, which requires 2 number of hosts, okay, and then the information for the network address, CDIR, as well as first host and broadcast address are already given here. So again, these answers were derived or were computed using our provisions here on our part 1, which allow us to examine network requirements. So now we'll be proceeding with our step 2, or completing the device interface address table. So assign the first host address and the subnet to the Ethernet interfaces. BR1 should be assigned the first host address in the BR1, BR2 link. So we have here 2 devices. So namely BR1 and BR2, as what you can see here, this one in the middle, that's BR1 and that's BR2. And then we're going to have here their interfaces. So the GPIO inputs for the Cisco components, and then each of the device which have individual interfaces respectively, unique to them, has different IP addresses as well as subnet mask, as well as device interface. I'm not going to be mentioning it one by one, but if you're going to be observing, both the subnet mask of BR1 and BR2 here below are the same. Okay, then we'll also have here this one. Their device interface is also the same. So for part 3, we'll just be following this paper. Okay, we're gonna be configuring the IPv4 network of our cable. So we'll be needing 2 routers. Okay, then we will also be needing 2 switches in accordance to the topology shown above in our paper. Okay, so the 2 routers will be in the middle of the 2 switches as shown in the topology. Okay, let's just fix the layout. And then we're gonna be connecting these components, okay, these devices in accordance to the topology that we have above. So as you can see here, we're gonna be connecting these devices using our copper straight through cable. So switch 1 is connected to the router 1 through this connection. Just take note how I connected it in our packet tracer, as well as our router 1. That will be connected to our router 2. And then the router 2 will be connected to our switch number 2 as well. So now, after connecting all of our devices, okay, we'll be configuring it, okay? We'll be configuring our routers. So we're just gonna have to follow the instructions given below from part 3 up until we finish configuring all of the routers, and after that, we'll be testing by using the ping command if they already have a stable connection. So the first we'll be doing is that we're gonna be changing the host name. Okay, we're gonna be changing the host name of router 1. Let's start the process on our router 1, and then on our router 2 we'll be just imitating the process we did on the router 1. So we're gonna be changing the host name of our router 1, And then we're gonna be disabling the DNS lookup using the command, okay, that we've learned. And then, okay, and now we'll be assigning the IP addresses of our router one, okay, as well as the password. We'll be assigning the password, okay, and we'll be assigning the password for our console. We assign the password for the exec mode, privilege exec mode, and we also assign the password for our console line. And then we'll be assigning the password for our line BTY. We also consider the subnet mask. Okay, we also consider the subnet mask for the IP configuration. The next one, we're going to be encrypting all of the password. Okay, we're going to be encrypting all of the password. We're going to be using Cisco as our password as well for our console. And then we're just going to have to register the command in order for it to work. Then we're going to be encrypting all of the password, meaning it should be hidden. It should be hidden to provide privacy and to avoid hackers. And then next one will be, okay, we'll be creating an MOTD banner that will display a message that an authorized access is needed for the user to be able to access the link. And then after this one, we'll be having the step 3, configuring the interfaces on each router. So we're going to be configuring the interfaces using the IP addressing table here above. Okay, just take note of that. We'll be following that one. So just follow the commands that we have here on our screen. Okay, and we're going to be using the specified IP addresses that is in the addressing table. Okay, so just watch the video all throughout, and then after configuring all of the IP addresses, considering all of the subnet masks, as well as our device interface or our description name, we're just going to be repeating the process for our router number 2. And after that, okay, we can have a way to make sure that there is a stable connectivity between the routers by using the ping command later on that I will be showing you. So just keep on watching the video, and I hope you learned a lot from the demonstration. Now for part 3, we're going to be testing the connectivity of both of the routers, okay, by using our ping command. So for the first procedure, we'll be using the ping command under the R1, wherein we're going to be testing the connectivity of R1 to R2, or let's say to our router 2. So we're just gonna have to ping the IP address of the router 2, okay, from the router 1. So we're just gonna wait for it, okay. So let's type the IP address here, which is the IP address of our router number 2 with respect to our router 1. So let's ping it and let's check if there is a connectivity. Okay, as you can see here, there is a connectivity between router 1 and router 2. The next one, we're going to be pinging router 1 from router 2. So let's open router 2 here and let's ping the IP address of R1 from our router 2. So let's ping it. So let's ping the IP address of the router 1. Okay. Then let's wait for it to load up later on to make sure that there is a connectivity between both of the routers. So as you can see, there is a connectivity between both of the routers, which signifies that we did the configurations correctly. So that's all for our experiment. Thank you and see you!